Alright, in this video we're going to talk about linear programming, and that is a method for finding a minimum or maximum value of some quantity given a set of constraints. Now let's just talk a little bit about some of the vocabulary that you'll see in this lesson. The first word is, words would be objective function, and that is the quantity that you're trying to maximize or minimize. Next, you'll hear the term constraints, and those are inequalities that describe the function. Those are the conditions that are happening in the problem. And then the last one is feasible region, and that is all of the points that satisfy all of the constraints. So if you were to graph these inequalities, the region that is the solution, the region that works for all, are the points that work for all of the inequalities, that is your feasible region. And now let's do a linear programming problem. So you want to spend no more than $40 for at most 15 tomato plants. You want to maximize the pounds of tomatoes you get. How many of each plant should you buy? So we have Roma tomato plants. They are $2 each, and you get an 8-pound plant or 8-pound yield per plant. Cherry tomato plants are $3 each, and they give a 10-pound yield per plant. So let's call the number of Roma plants X, the number of cherry tomato plants Y. And so the first thing we do to maximize a linear function is write constraints or inequalities. And so to decide where we start, we look at what we're given for information. You want to spend no more than $40. So we're going to write an inequality that deals with the amount of money that we're going to be spending. So we know that the Roma tomato plants are $2 each. So 2 times the number of those. And the cherry tomato plants are $3 each. So 3 times the number of those is no more than 40, which means it's less than or equal to 40. Then they tell us that we're going to buy at most 15 tomato plants. So the number of Roma plants plus the number of cherry tomato plants is less than or equal to 15. And X is greater than 0. Y is greater than or equal to 0 because we don't have a negative, we won't buy a negative number of plants. So next you graph those constraints, and when I graph these I like to graph the intercepts. So if you cover up the Y, so if the Y here is 0, your x-intercept, you have 2x equals 40, so the x-intercept is 20, and to find the y-intercept, x would equal 0. So if we put in a 0 right here, you would have 3y equals 40. And if you divide by 3, y would be 13 1/3. And so you plot those points. So 20, 0 is right here. 0, 13 1/3 is about right here. And those are 2 points on the line, so then you can draw the line through those points. So that's a nice way of graphing line or equations that are in standard form. To graph the next one, we have x plus y is less than 15. So if y is equal to 0, x would be 15. So 15, 0 is a point. And then this, if x equals 0, y would equal 15. So 0, 15 is a point here. And you draw that line. Now, both of these inequalities, if you test the point 0, 0, in 0 plus 0 is less than 40, 0 plus 0 is less than 15. So they're both graphed below. And so the feasible region here will be this area through here. This is where the overlapping would occur. And since x and y are both greater than 0, it's just the first quadrant that we're dealing with. So now we write down the coordinates of the vertices. So we have 0, 0, and we have 15, 0. My pen's not working. And then we have 0, 13 1/3. And then right here, you want to graph very carefully. Your intersection is at 5, 10. And so we're going to evaluate the function at each vertex. Now, the function that we're trying to maximize is the number of pounds that each yields. So we'll call that a p function for pounds. So the number of pounds given x and y at different places here would be, let's see, we have 8 pounds for each Roma tomato plant, 10 pounds from each cherry tomato plant. So this is the profit, or not your profit function, this is your objective function that will maximize the number of tomatoes, pounds of tomatoes we get. So we'll substitute in those values, those coordinates, 0, 13 and a third, 0, 0, 15, 0, and 5, 10. And so 8 times 0 plus 10 times 13 and a third would be 133. And then 0 plus 0, that just gives you 0. And then 8 times 15, my pen went a little crazy there. That gives you 120. And then lastly, 8 times 5 plus 10 times 10, that would be 40 plus 100. It's 140. So right there is where we get the maximum number of pounds, and that is when X, which is the number of Roma tomato plants, would be 5 and 10 cherry tomato plants. All right, one more problem. You are screen printing t-shirts to sell for a fundraiser and are working with the following constraints. You have at most 20 hours to make shirts, which is 1,200 minutes. You want to spend no more than $600 on supplies. You want to have at least 50 items to sell. Now, the long sleeve shirts, those take 30 minutes to make. The supplies cost $20. The profit is $20. The short sleeve shirts, they take 10 minutes to make. Supplies cost $4. The profit $6. How many long sleeves and how many short sleeves do we want to make to maximize our profit? How much is the maximum profit? So we'll call X the number of long sleeves, Y the number of short sleeves. So now we write our inequalities. So the first constraint is you have at most 20 hours to make shirts, which is 1,200 minutes. Well, let's look at how long each takes. It's 30 minutes to make the long sleeve shirts, so 30 times the number of those. 10 minutes to make the short sleeve shirts, and that has to be at most 20 hours. But these are in minutes, so we're going to use the 1,200 minutes then. That has to be less than or equal to 1,200. So we're using the same unit all the way through. Then next, you want to spend no more than $600 on supplies. Well, the long sleeve shirts cost $20. The short sleeve shirts cost $10, and that is going to be less than or equal to 600. And lastly, it says you want to have at least 50 items to sell. So the number of long sleeve shirts plus the number of short sleeve shirts has to be greater than or equal to 50. And of course, we're not going to make a negative number of shirts. So X is greater than or equal to 0, Y is greater than or equal to 0. Now, when you graph those lines, and I use the intercept method, if I cover up, if Y is equal to 0, X would be equal to 40, and I'm counting by 5s here. So this is the first graph. And then your Y value is 120 up here. So that's the first equation, drew that line. The next one, your Y-intercept, if X is 0, would be 150. So that's way up there. And then the X-intercept would be 30. So that's right here. And then those are both shaded below, because if you test 0, 0, that's less than 1,200, 0, 0 is less than 600. And then this next one, X plus Y, is greater than or equal to 50. If you test those points, 0, 0, that doesn't work. 0 plus 0 is not greater, so you have to shade the other side. So this is where your overlapping is going to occur in this function. This region right through here. So this is your feasible region. So those vertices would be 0, 50, 0, 120. We have 25, 25. And this one right here is at 15, 75. So the profit equation for this one would be, let's see, $20 for each long sleeve and $6 for each short sleeve. So we just substitute in all of those vertices there. So we have 0, 50, 0, 120, 25, 25, and 15, 75. So 20 times 0 plus 6 times 50 would give you $300. And 0 plus 6 times 120 is 720. That gives us $720. And then 25 times 20 is 500, plus 6 times 25 is 150. So that would be 650. And then we'll substitute in 15. 20 times 15 is 300. And 6 times 75 is 450. That gives us 750. That is where we reach maximum profit. That is 15 of the long sleeve and 75 of the short sleeve, and that gives us a profit of $750. And then real quick, I just want to graph one of these because these are some equations that we haven't graphed yet. We have y is greater than or equal to 2. I shouldn't say equations, inequalities, excuse me. Y is greater than or equal to 2. When you have y equals a number, those are horizontal. So on the y-axis, you go to 2 and draw a solid line. And it says y is greater. So we put our pen on the y-intercept and the y's are greater this direction. So that would be shaded above the line. And the next one, that is a compound inequality. It says x is greater than or equal to 1 and x is less than or equal to 5. So x equals our vertical line. So you go to 1 and we draw a vertical line there and go to 5 and draw a vertical line. And it says x is between there. It's x is less than 5, less than or equal to 5, and greater than or equal to 1. So it's everything through here. And then lastly, we have the equation y is less than or equal to x plus 3, the inequality. I always want to say equation. The inequality, y is less than or equal to 3. So the y-intercept is at 3, and the slope is 1. So rise over run is up 1 over 1. And just graph very carefully so we get those points of intersection. And you draw your line there. And that, it says y is less than, so put your pen on the y-intercept, which is right here, and y is less than, so it's going to be everything below. So where the area where these intersect would be right through here. And so what you want to do is write down those coordinates of the vertices. So here we're going over 1 up 2. Here we're going over 1 up 4. We have this one, this one. Oops, that's 5, sorry. It's messy, you have to be really careful with your graphing. And then here we're going over 5 up 2. And then over 5 up 2, 3, 4, 5, 6, 7, 8, 5, 8. Actually, I think this is a 4. We're going to go 1, 4 right there. All right, so those are our vertices, a little messy there. Now we're given an objective function here, 3x minus 2y and 2y. So what we do is substitute in the x and y for each of those. So 3 times 1 minus 2 times 4 would be 3 minus 8, which is a negative 5. And then 3 times 1 minus 2 times 2 would be 3 minus 4, which is a negative 1. And 3 times 5 minus 2 times 8 is 15 minus 16, which is a negative 1. And 3 times 5 minus 2 times 2 is 15 minus 4, which is 11. So this is where our maximum value is. It's at 5, 8, and you get 11. And the minimum value occurs at 1, 4, which is a negative 5. And that's what I have for you on linear programming. So let me know if you have questions. Thanks for watching.